Hello everybody, today's homework help video is coming to you for section 323. We're going to be looking over most of the problems from this section, starting out with 78A. Now in 78, they give you the instructions that they want you to simplify the expression below. We kind of talked about in class where just because you see two x's doesn't mean we can just immediately take those away. So if we look at this, our first thought is, oh, this is super easy. All I'm going to do is I'm going to take away these x's. They're going to cancel out. But remember, we talked about the problem with that is that x minus 2 over x plus 5 is not always equal to negative 2 over 5. And the reason being that the operation we're doing is addition and subtraction. If that had been multiplication, if we had had x times 2, x times 5, then it would have been equal to negative 2 over 5. But that addition and subtraction are kind of what are tripping us up right now. So the same is true when we try to simplify this expression. Remember, we had x squared over So when we're looking to simplify this expression, what we're going to want to do here is our first step is actually going to be to factor. And so you guys are going to get more practice factoring it all out. So I'm going to go do this one step by step. So first when we factor, we're going to factor the top and then the bottom. So we're going to kind of break it up into chunks. Remember when a problem in math seems really complicated at first, the easiest thing for you to do is break it up into smaller things that you know how to do. You know how to factor, so let's do that. If I'm looking at the top, I want to factor it. I'm going to do my diamond. So I'll have 16x squared at the top and negative 8x below. What I find is that I'm going to have negative 4x and negative 4x, which will give me a positive 16 squared, and add together to be negative 8x. Take that and bring it down to my rectangle. Fill in what we know. We need an x squared, and we also need a positive 16. All right, and we just found out we have negative 4x and negative 4x. We can see that what we're going to end up with is, if we pull out from the top, we've got a negative 4 and below an x. On the other side, we pull out an x and a negative 4. We can see that negative 4 times negative 4 gives me positive 16. And so on the top, what we really have is the quantity x minus 4 times the quantity x minus 4. And there's that operation that we want, that times. Remember, the operation between these two guys is multiplication. All right, so what we did to the top, we're going to do the same thing to the bottom. If we look below, we'll do our diamond. On the top, we should have a negative 24x squared, and below a negative 10x. What we're looking for is going to be a positive number and a negative number. Let's see, let's try negative 12x and positive 2x. Now we'll put it in our rectangle. We have a 3x squared and a negative 8. And we know we want to have a negative 12x and a positive 2x. On the top, we want to pull out negative 4. Below, we're going to pull out just an x, which you can kind of see how that's going to help us out with the top. We should be looking for something to be canceling out if they ask us to simplify. And then below, we'll pull out a 3x and a 2. So when I write this below, we have the quantity x minus 4 times the quantity 3x minus 2. If you go back to 78A, there was a little bit more information other than just what they wanted you to simplify. They also told you that this does not work when x is equal to positive 4 and positive 3 halves. And so when we look at that, we can see why that's happening, right? If we were to plug 0 in, or if we were to plug 4 in on the bottom, we'd have, with our x minus 4, we'd have 4 minus 4, which would give us 0, which would be bad. We never want that to happen in our denominator. And so what those answers are, where it says x cannot be 4 and x cannot be 3/2, is actually a hint on what you should be looking for in the bottom when you factor it out. So now we can take, and we can cross out anything that factors out. You can see that we have an x minus 4 on the bottom and on the top, and we'll be left with x minus 4 over 3x minus 2. And we have now factored it completely. We have simplified it completely. That is as simplified as we can get it. All right. Moving on to part B. Part B is very similar. If we look, we want to factor it out. And so on the top, when we say factor it out, we're actually just looking to pull out a greatest common factor. We don't have x squared, so we know that we just want to see if we can pull out anything extra. And so on the top, we see that the number they share in common between 10 and 25 is we could pull out a 5 for both of them. When we do that, we'll be left with 5 times the quantity 2x plus 5. Below in our denominator, we are going to need to factor, so we're going to take that to our diamond first. We will have negative 30x squared on top, negative x on the bottom. And so we're looking for a positive number and a negative number. You know, my negative number's got to be bigger by 1. So we're looking at a negative 6x and a positive 5x. Filling in our rectangle, we'll have 2x squared, negative 15, and then we have our 5x and our negative 6x. And on top, we can pull out a positive 5, and then up below, we've got our 2x. Below we have an x, and our negative 3. I think I have done something wrong. We should have 2x plus 5 and x minus 3. Oh no, I'm good. All right. So now I'm going to fill that in to my denominator. So I have the quantity x minus 3 times the quantity 2x plus 5. And that's good because we're looking for something to cancel out. Hopefully you can see what we need to get rid of in order to simplify. We look for what the top and bottom share in common, which is this 2x plus 5. It'll go away, and we'll be left with 5 over x minus 3. Moving on to part C. Part C is a lot of the same, except they've added an extra step. Here they have us dividing. But before we do that, let's simplify before we divide to make our lives a ton easier. So first, what I'm going to look for is in my first fraction, what they have in common is this 2k plus 1. So I'm going to cancel that out. That means on the bottom, I'll be left with the quantity k minus 4 over 5. And we're going to divide that by, looking for what cancels out, that k minus 3. We'll have k minus 4 over 10. So we know that if you want to divide, the easiest way to do this dividing fractions is to just multiply by its reciprocal. So we're going to multiply this by 10 over k minus 4. I'm going to leave that in parentheses. So when we pull it over, we've got 10 times k minus 4 over 5 times k minus 4. We see that we can pull out that k minus 4. We're left with 10 over 5. That's the same thing as 10 divided by 5, which is the same thing as the number 2. Who would have known all that craziness would have ended up in just the number 2? All right. Moving on, I'm skipping most of 80, A and B. It's a lot of the same. Mostly they just want you to know that how can we rewrite things so that they're easier to solve, right? So we look at, well, everything here is being divided by 100. I know that my life would be a lot easier if I didn't have that divided by 100. They all have that common denominator of 100. what I'm going to do is I'm going to take and multiply everything by 100. That'll leave me with x plus 3 equals 8. And how easy is that? What plus 3 gives me 8, or subtract 3 from both sides, x equals 5. And they just want you to see that we can always rewrite expressions as long as what we do to one side of the equation we do to the other side of the equation, making it the same equation and true. You know that if you had decided to maybe rewrite it as a decimal, you still would have gotten the same answer of x equals 5. Moving along, we have kind of a flashback where we're talking about inequalities. They want you to solve for x, and then they also want you to put it on a number line. So when we do this one, it's kind of like solving for x. When we have an equal sign, where 3x is less than 0, we know if we divide both sides by 3, we will still have x is less than 0. So when we plot this on the number line, I'm going to throw in some numbers. I'm going to put 0 here, 1, 2, 3, negative 1, negative 2, negative 3. We cannot include the 0, so I'm going to put an open circle on it, and then we want everything less than. Then part B. Part B, it's got one of the special properties, but they're imagining you're going to do first is you're going to decide to add x to both sides, which you can absolutely do. When we do that, we're left with a negative 2x is less than or equal to 8. And then there's this special rule we have to follow, and that's when we divide by a negative, it's going to flip our sign. So instead of being x is greater than, it is now going to read x is less than or equal to negative 4. So when we put that on our number line, 0, 1, 2, 3, negative 1. Oh, maybe I'm going to start this a little bit. Negative 4, negative 3, 2, negative 1, 5, 6. And so we've got it is less than or equal to, which means we can put a closed circle on negative 4, and we want everything that's going to be less than negative 4. Again, the trick here is just realizing that when you divide by a negative, it's going to end up flipping our sign. All right. 82A. Hopefully you guys don't need too much help with this. It was kind of fun for me. It lets us talk about the different properties of dividing and multiplying and kind of seeing how these greatest common factors come into play and getting things to equal out 1. All right, so when we do this, they just want us to do it without a calculator. So really what this comes down to is, on the bottom, we have 2 over 3, and then 9, if we want to break it down into its different factors, if we break it down to its prime numbers, 9 has 2 primes, it's 3 times 3 equals 9. And on the bottom, 14 has 2 prime numbers that go into it, it's 2 and 7. And then they want us to look for things that create a 1. So we know that 2 divided by 2 gives us 1, and we know that 3 divided by 3 gives us 1. So what we're left with really is 1 times 3 over 7. And 1's got that special property that says anything times itself is whatever that number is. So we're left with 3 over 7. Part B, they've got you dividing. We know that when we divide, the easiest way to do it is to flip it around. So we'll have 3/5 times 25/12. Again, I'm going to do the same thing. We know that this is really, I'm going to write it in 3. We know this is really just 3 over 5 times, breaking 25 down into its primes is 5 times 5, and 12 into its primes is 3 times 2 times 2. Our 5's cancel out, 3's cancel out, and so we're left with 5 over 2 times 2, which is 5 times 5 over 4. All right. Jumping now to 83. In 83, the first thing they ask you to do is to sketch a graph. I sketched the parent function first, and so you're looking for the graph. It should look something like what I highlighted in blue. In part A, they ask you to draw the parent function, and so what they want you to see is that if we start out with the parent function, it kind of looks like that sideways S. And our new function still looks like that sideways S. It's just been moved to the left -2 and up 4. So we've got it in that nice vertex form where we can see that for our x value, we need to move it over to the left -2 and up +4. So it looks just like its parent function, except it's just been shifted. And then when we go to 83b, they ask you to rewrite it, I believe, and they want you to just basically expand it out. Yes, it says to rewrite the equation without parentheses. And so what they want you to do is you should know that this quantity x plus 2 to the third is really the quantity x plus 2 to the third times itself 3 times, and then just add 4 to it. Before you start going and foiling all of that out, take a minute. There is a shortcut that can help us write it a lot faster, other than factoring out a bunch or foiling it out a bunch of times. We can follow this form where if we let x equal a, so we'll let a equal x and b is equal to +2. So we'll plug it into that shortcut that I provided. This will make it go a lot faster. So we will have x to the third is just x to the third. Then we do 3 times a squared plus b, which is the same thing. Remember that b is going to be a 2, so we'll have a 6 as a coefficient, a squared, plus 3 times a times 2b. 2b squared is going to be 2 squared, which is 4. 4 times 3 is 12, and then we're still left with our x. And then we do b to the third, which we know will be 2 to the third, which is 8. And then don't forget about that plus 4 at the end. We'll combine our like terms. We'll have x to the third plus 6, and then we'll decide that a is supposed to be an x, plus 12x plus 12. All right, and so then in part C, they say, what's the difference between, they say, how would you graph part A, or how would the graph in part A differ from the original equation? So we see this form here. We've got what we just found to be when we expand out the equation, and then they want to see, well, how would that be different if the function was written in vertex form? And what they want you to know is that just because they look different doesn't mean they're a different equation. We could plug this into our calculator as well, and we should find that we get the same exact graph. They're the same exact equation, they just look a little bit different. This is that idea of being able to rewrite equations and still have the same graph, still having equivalent equations, having them be the same. All right, and then last one in 84. First, they ask you to sketch the graph of the function. So I did it on a calculator online. This is a great site if you don't have a graphing calculator and want to be able to use it at home. I just plugged in our function, and you can see it's graphed in red. So it should just look like that red exponential graph. So that in part A, they ask you, what is the domain? And so the domain is, remember, that value of x, what can we plug in? So is there anything we can't plug in? That's always a good spot to start. Is there something that doesn't work for x? Well, thinking about exponents, we know we can raise negative exponents, we can raise positive exponents, and we can raise it to 0. We know they can be fractions, they can be decimals, they can be whole numbers. So really, what we plug in for x can be anything. So our domain is going to be all real numbers. The math shorthand for that is just a fancy looking R. And then in part B, they asked you to sketch the graph of the geometric sequence. So here's the part where it gets a little weird. We noticed that before, when we graphed it, we got that nice continuous line. The idea of something being geometric is that there's a special sequence that it goes in. If you remember, we had one where it was figures, where it was like dots. The first one had 1 dot. The second one had those 3 dots. The third one had 5 dots. And so when you think about a geometric sequence, it has to start out with the first term. there's no such thing as that negative term. We're not trying to work backwards to anything. It's only got a first term, a second term, a third term. And so when we think about these values of x, they can only be positive numbers. We're not going to have any zeros, and we're not going to have any negatives. Same thing also is that we're not going to have any decimals. There's no such thing as the 1.5 term in the sequence. We can only have whole numbers. And so when you go to graph the geometric sequence, all it's going to be is it's just going to be isolated points. It's not a continuous line. It's just points on a graph. If we were to, this calculator doesn't allow me to do it as a geometric sequence, but I want you to kind of imagine is it can only be, we talked about it, how it can't be any of these negative numbers. So I kind of highlighted them really quick. We can't have any negative values of x. We can only have positive numbers. And then, so it's got to be our 0, 3, or sorry, we can't even have 0. No 0, 3. It's got to start with 1. 115, 275, 3, 375, and 4, 1,875, right? So you can't really graph them on here, but they would just be isolated points. So if you can imagine, we would have our number line, and then we could only do positive x values, so we could find the first, the second, the third, the fourth, the fifth, and so on. And we see that on the calculator it says we're at 115, so you have to imagine 115, and then like way up here is going to be our second term, so it's a nice exponential, at 275. And so we've got our next point all the way up here, and it's going to create that exponential line, obviously going through the point. So all I want you to see is when we have a function is continuous, and it works for all values of x. When we have a geometric sequence, it is not continuous. It's just going to be dots on the graph. And then, yes, and we can only have 1, 2, 3, 4, 5. Obviously, the mistake I just made when I was explaining it was that it can only be those dots. And then even higher will be that third term. So just points on the graph for our geometric sequence. Hope that answers all of your questions. If you still have some questions or I didn't cover one that you had a question on, please feel free to come see me in class. Hope you guys have a nice